if task 1 can be performed n1 ways, which means in this case it will be more like our status. That would be what? A task 1, right? And then this 3 here refers to how many status you have. That's like the number of ways. And then if task 2, which for our example, so this would be like task 1, that would be task 2, okay, can be performed in n2 ways. In this case here, the n2 way is referring to that 4. Obviously, this will be n1, right? Then the number of ways, in this case here, the number of meals that, in our case, we have got 3, but in this statement we have got 2. But it can be extended. It doesn't apply to only 2 tasks only. It applies to at least 2 tasks. Okay? So in our case, we have got a third one. This will be like N3. Right? Now, if you want to determine how many ways can a person choose a combination of 1 starter, 1 meal, one main meal, and 1 dessert, what you have to do is you have to multiply the number of starters by the number of main meals by the number of desserts for you to get the total possible number of choices, okay, of each of those 3. Right? Here we are assuming that if a person goes to a function, they have to, it will be compulsory for them to have at least 1 starter and 1 main meal and 1 dessert. Of course, we know that in real life, some people might skip the dessert because probably they are very hungry. They rush straight away to the main meal. All right? Okay? And some people, instead of starting with a starter, they can skip that and then they can have a dessert first.
Some will eat, sir.
Like some they don't.
No, like they will eat some before the wedding, sir.
Okay, some they don't even eat. Alright.
That's normal.
Alright. So based on the fundamental counting principle, all you have to do is just multiply those number of ways. Multiply them. And then you get the possible number of choices. The total number of choices, you get it by multiplication. The fact that in this situation we multiply the 3 by the 4 by the 4 and we get 48. It means that we are using what is called the fundamental counting principle. Now, your grade 12 maths, the last topic was this topic is part of maths paper 1. The last question will be on probability and the counting principle. It will be mainly grade 10 and 11 work plus the grade 12 component, which is on the counting principle. All right? So just copy that down quickly. My introduction, then you shouldn't have any problem with this question. Right? So the question, listen. All right. So here we have got an example. The question says there are 3 vacancies at a specific company. So it means there are 3 positions that have to be filled. The company had shortlisted candidates for each position. Right. So we have got in the first column the post, that is admin clerk. Then there were 3 candidates that were shortlisted. We have Ben, we have Sandile, and we have got N. Then for the post of an accountant, we have Donald, we have Chabo, Chekobo, and then we have got Lydia. And then for the personal assistant for the CEO, there are 2 people, Dorothy and Spongile. Right. Now the first question now says, okay, that's A1. Now A1, it says, how many ways can these positions be filled? How many ways? So we say number of ways. Okay? We start with the first task, which is the admin clerk. Right? There are 3 people. So based on the fundamental counting principle, we get 3 times the number of people shortlisted for the accounting post as 4 times the number of people shortlisted for the PA, the CEO, that's 2. So the answer there will be 24 ways.
Yes.
Okay. Alright? So this is straightforward. Then number 2 now says, how many ways can the position be filled if it is certain that Donald will get the job as an accountant? Now be aware that that 24 there, it means that any of those candidates might fill, let's say if Ben had applied for an admin clerk position, right? Probably they might have the credentials that will qualify to be an accountant or a PA. So this 24 here is taking into account that. But number 2 now has got a restriction. And the restriction is that Donald will get the job as an accountant. So it means being an accountant, only one person out of those 4 can take it. Right? So to do that, or to get the answer for 2, we'll say, okay, we'll use a technique. Okay, I'm just going to show you this. We have got 3 positions. So let's say this is the first position. I'm going to represent it by a horizontal line, then the second one, then the third one. Now, how many people can take the position of the admin clerk? It's what? 3. Right? Then the accountant now, it is a fixed position out of the 4. The probability is 100% that Donald will take it. So only one person can take that.
What?
All right?
Yes.
Okay.
Wait, that's a whole piece of that.
I don't know if go back. I highlighted it.
Can you tell me how to get to one?
No, it's the one.
Yeah, because the question says if it is certain that Donald will get the job as an accountant, means only one person can be an accountant, and that's Donald. The other 3 cannot qualify. Though in the first question we put 4 here because there was no restriction. But here we've got a restriction. And the restriction is that Donald has to be the accountant. So only one person is going to take that position. Right? Then the last position can only be taken by all 2 people. Then we use the fundamental accounting principle. So the number of ways will be equal to 3 times 1 times 2, which is 6 ways. Okay? Are you following them? Huh?
So, no. The second question says that it's the job won't be able to fund, so excluding the other.
Yes.
Example is the only one.
Yes. Only one person can take it, and that person is Donald. The others, there is no chance. Okay? There is no chance.
Maybe Donald was passing that.
Well, let me carry on. Right, the next example. Now, the question is more or less the same. It's just the use of the counting principle. That's all. So don't be negative. So the question says, in the diagram below, there are 3 routes from A to P. So from A to P, 4 routes from P to Q, and there are 2 routes from Q to B. How many different routes are there from A to B via P and Q? Okay, in the direction of the arrows. So this is not complicated. If you have understood the concept of the fundamental accounting principle, then it should not be difficult. So the 3 routes are going to be the following. So from A to P, there are 3 choices. All right? From A to P, there are 3 choices. Then P to Q, there are 4 choices. Q to B, there are 2 choices. Then we use the counting principle for number of routes. It will be equal to 3 times 4 times 2. And this will give you 24 routes.
So,
Yes?
where does the achieve that?
Okay. Remember, we are just starting. Okay? We are just starting. Right? I cannot just start with the complex questions. Yeah. So we are starting with the easiest questions. Right? Are you following here? It's very, very important for you to understand the fundamental counting principle. Kize. Right? It's very important for you to understand the fundamental counting principle. Right? Then let's move on to a new case now, or a new scenario. Now, sometimes there may be repetition of objects. Okay? Sometimes there can be repetition of objects. Sometimes the repetition can be people. It can be things like cities and so on. It can even be you in terms of where you are sitting. Right? So there are two cases. Either we can allow repetition of objects, or we may not allow repetition of objects. Now, in the case where repetition of objects is allowed, we use what is called the exponential form, right? So in cases where repetition is allowed, we can use this simple formula: number of possibilities is equal to n to the power of r. Sometimes the r can be equivalent to the n, okay, or the n can be equivalent to the r. There are sometimes where n is the number of options to choose from, and r is the number of times we choose from these options. Don't stress about this, because I'm going to show you an example of what this formula is saying. So on the next page, I'm going to do an example. Now, generally, please take note, when repetition is allowed, we use exponential form. Okay? You understand just now what I mean by exponential form. So this is the exponential form, which is only used when repetition is allowed. So I'll indicate here, used only when repetition of objects is allowed. It can be letters in a way. Repetition of objects is allowed. Okay? Don't worry, I'm going to show you an example now. Just now, yes.
So, like, in the community,
No.
you know, something so like when maybe someone has 2 million, something like that.
Okay. I think, yeah, I don't want to give you an example in terms of news. Uh, Let me give an example of a word. What? A word. Remember, the English alphabet has got how many letters?
26.
26 letters.
Oh.
Right? Now, let's say if I ask you a question, how many three-letter words can you make? Okay? Don't worry whether the words have got meaning or not. Right? How many three-letter words can you make if the 26 letters can be used to form those words, and repetition of the letter is allowed? Okay, so what I'm saying is,
78.
Yes.
what I'm saying is, you need to make a three-letter word, right? A three-letter word using the 26 letters, but you can repeat the what? You can repeat a letter, which means you can have all three in the three positions of that word. How many possible words can you have?
17,576. I know I'm right, that's it's mine.
How would you get
26
yeah, 26 cubed.
Yeah.
So what we are saying is the first position can accommodate all 26 letters. The second, all 26, because the repetition is what? Is allowed. Then the third one, 26, can also take that position. Right? Then we use the fundamental counting principle. So 26 times 26 times 26, this is equivalent to 26 cubed, which is equal to 17,000 and what? 576 words. So the exponential form that I'm talking about, I'm sure you can see it here. Right? We use the exponential form if repetition of objects is allowed. Now, you get a different answer if the letters were not supposed to be repeated. Which means if there was no repetition, we have 26 here, then 25, then 24. That's another scenario now, which I'll talk about just now. So there are two ways that objects can be arranged. Either they can be repeated or they may not be repeated. Right? If repetition is allowed, then you use the exponential form. Right? So let's move on to a case where repetition is not allowed. Concept is the case where the repetition of objects is not allowed. Okay? When the repetition of objects is not allowed, means if you have got, in the case of the example of a three-letter word which is supposed to be formed by the 26 letters on the English alphabet, it means that if you want to make a word which has got three letters using the 26 letters, but the repetition is not allowed, means the first position can only accommodate all 26. They can fight for that position, all 26. But once you use a letter here in the first position, you can't put it there. So you're left with what? 25. Right? Then the third one is left with 24. Now, if we use the fundamental counting principle like that, it will be 26 times 25 times 24. Alright? Now, that one, we can use a new concept which is called the factorial notation. The factorial notation. But I'm not going to get into the details of combinations and permutations because that's not for your level. Right? So we use the factorial to do calculations when repetition is not allowed. Right? The factorial, okay, the factorials can be calculated using the exclamation button on your calculator. I'll show you this one here. Right? It's this one here. Is this one. So what you do, you press shift, and then you press that button. But if you want to use it, please, are you looking on your calculator? Make sure you know where it is on your calculator. So you press shift, and then you press it. That one there. But this is how you do it. First, you have to put the number first. So if I put 5, if I want to calculate 5 factorial, I know the answer by the way. Okay? 5 factorial. 5 factorial means 5 times 4 times 3 times 2 times 1. Okay? So
what's the answer, sir?
Your calculator, okay, what's 5 times 4?
20.
It's 20. Then you are left with 3 times 2, which is 6. 20 times 6 is 120. Right? So that would be 5 factorial. Right? Then you press equals, it gives you that. Okay? Now, we use this function whenever you have got questions on the counting principle where repetition is not allowed. But you have to be very careful. There are some cases where we also use this function, this one here. Now, like in this situation here, okay, I'm going to explain it as we go through. We have got 26 letters, right? But we are supposed to choose how many? 3. So what you do, you say 23, you're going to get the answer. Can someone just do a calculation for this answer?
15,600.
So we get 15,600. Right? Here we are using the fundamental counting principle. If we use the calculator, then we have to use this function, but generally in your case, you guys, you won't use it a lot. So that should be 23 letters. So the 26 rather, okay, let me start calculation. 26, right? Then you press shift, then you go to number 6 on my calculator where it says NPR here, where there's a times, depending on your calculator. So if you press that, okay, it gives you P. P stands for permutations. I'm not going to get into the details, but permutations is just objects that are arranged in a specific order. That's a permutation. Then out of the 26, we are only choosing what? 3. So the R there represents the 3. Now check this. You get the answer. 15,600, which is what you got using the counting principle, right? So we use This one here.
So,
Yes.
so if you want to choose like one for 26 places, you use the first one.
Well, you can use both of them. But now the first one, the factorial, right? It's not going to help us here directly. This factorial here is accommodated here.
What I'm saying is, if you want to, like, from the 26 places, you have to choose, you have to make up a word that has 26 letters.
Yes.
Then you use the first one, exclamation mark.
Yes. Yes. Okay, do you hear what he's saying? I like that because you are thinking. He is saying if we were to make a word which has got 26 letters, then we have to use the first one. That's true because you are going to end up having 26 times 25 times 24 times 23 up to times 1. Therefore, you can use what? The first button, this one here. But don't worry, I'm going to explain it now. So, for the first case, for the factorial, right, n factorial is the same as n times n minus 1 times n minus 2 times n minus 3 up to, okay, in this case we get 2 times 1. Okay, that's what n factorial means. Now, the button that I just showed you on the calculator, the NPR, it's n choose r, right? So you have the total n, and out of the n, you only want to choose a specific number, or a fraction, or a portion. So this one here, we can write it as n factorial divided by n minus r factorial. That's the formula for this now. Okay? But my suggestion, that's why I say the NPR function, it accommodates the factorial. Okay? As you can see, the numerator is equivalent to n factorial, but the denominator now, you are subtracting r from n. Then you find the factorial, that will be your denominator, then you divide, and then you get the answer. So we use this one in a case where we are only choosing out of a specific total. Okay, that's when we use the NPR function. Sorry? The R are the choices that you are choosing from N. Here, R is less than N. R is part of N. Like here, how many letters are we going to choose in order to make the word? We've got 26 letters in total, but out of the 20, we only want what? 3. So those 3 are like this R here. Right? Are you following them? So we use the factorial if repetition is not allowed. Repetition of object is not allowed, then use the factorial. Can you stop that? Right? Are you following? Right, let's do an example. Okay, if you've got a question, ask.
There's no repetition, so how come there's 26?
Okay, one deal. If you are supposed to form a 3-letter word using the 26 letters of the English alphabet, but repetition of letters is not allowed, which means you can't have a word, please, the word might not have a meaning. You can't have a word like, say, N. You can't. Okay? That's what it means. No what? Repetition. You can have N in the first position, but you can't have N here or N there. You can have N in the second position, but you can't have N here and N there. That's what repetition means. That's what no repetition means. So we are saying if there are 26 letters, means the first position can accommodate all what? 26. So if you put a letter here, you can't put it in the second position. So how many are left? How many are left? 25. Can you stop the negativity? Because this is very simple. If you have got 26 letters, you use 1, how many are left?
26 minus
it will be 25, and then if you use a letter, pay attention, if you use the letter in the first position, yeah, you can't put it here, so you choose the second one. So you we have used 2. So out of the 26, how many are left? 24. Are you following them? Okay. Then let's move on to an example. Now, when it comes to digits, right? All questions, before you answer a question on digits, be very careful. If the question specifies the digits, that's straightforward. But if it doesn't specify, how many digits do we have in total? If it's a general question, not numbers. There's a difference between numbers and digits.
9.
Oh,
There are 10 including the 0. Right, so we've got 10 digits from 0 to 9, that's 10. Those digits are the ones that are used to form numbers. Okay?
Oh, didn't know this.
Alright. Okay, so check this now. The question says, using the digits 1 to 7, right? How many 2-digit numbers can be formed if digits can be repeated? Right? If the digits can be repeated, then it means we use the exponential form here. Okay? Use the exponential form. If digits may not be repeated, then we use the factorial form. This is very important for you to understand. So, for C1, if we wanted a two-digit number, right? How many digits do we have there? 7. So the first position, all 7 can take it. But because repetition is allowed, again 7 can also take the second one. So I'm sure you can see that the number of digits, number of two-digit numbers will be equal to 7 squared, which is 49. So that's straightforward, right? Then the second one, how many 4-digit numbers can be formed if the digits may not be repeated? Okay? If they cannot be repeated, you may have this scenario. The first position, all 7 can take it. But once you put a digit here, you can't repeat it there. So you'll be left with how many? 6. Then use the fundamental counting principle. So the number of 2-digit numbers, oh, sorry, it's 4. So if it's 4, then I can get, so here end up having 5, and then what? 4. Then you use the count, the fundamental counting principle. Right, so it's 4 then. So thank you for that. Number of 4-digit numbers. Now this one, we can do a calculation. This will be 5, and then that will be 4. Then we use the fundamental counting principle. Right? If you want, you can get the answer by multiplying 7 by 6 by 5 and then by 4. What answer do you get?
840.
840. Right? This is one way. Or you can do the calculation using permutations. So you are saying we've got 7 digits, so if it's 7, choose 4. Now 7 choose 4, you can use that on a calculator. This is the same as 7 factorial over 7 minus 4, that's 3, so over 3 factorial. What is 7 factorial over 3 factorial? 840. So you can decide which way you prefer. But I think most of you might prefer to do it this way.
So no, there are 7 people.
Right. But you can do it this way.
Where do you get again?
Huh? 7 choose 4 means 7 factorial divided by 7 minus 4 factorial. 7 minus 4. You can use this formula. The n is 7, the r is 4. So 7 minus 4 gives you 3. Are you following them? All right. Okay. Let's do. So I've got 4 minutes left.
That's what's nice.
So,
All right. I think for today I'll stop there.